All right. So just as kind of like a quick survey, who here has some experience with game development before? Okay, that's wonderful. Oh, we have one. We have a couple, maybe. Great. Okay. Um, have you all worked with Unity or with maybe some other game engine? Unity, nice. Um, cool. So, um, how many of y'all have, by any chance, written C sharp code before? A little bit. Yeah, we have a couple. How many of y'all have written Java before? Okay, that's great. You've all basically written C sharp. Um, as you know, the languages are very similar syntax-wise, so um, it's very convenient because we can just kind of write it, and then if your IDE tells you there's an error, you just like change a tiny thing, and then it'll be fine. Um, cool. So to kind of start off with, who here, even if you haven't done some game development before, who here wants to kind of explain what a game engine is? Doesn't have to be a perfect definition, but like kind of what do we mean when we like talk about a game engine? Yes. Yeah, so it includes stuff like some game logic, yeah. Um, basically, what a game engine is going to let us do is it has some tools built in that are common to basically all games. So all games have like a physics system, for example. All games need a way to render something to the screen. All games need a way to like read user input, right? Um, all games need, as we're going to see, a way of organizing data and having different objects that interact with each other. Um, so basically, the job of a game engine is to give us some kind of structure and some kind of systems that are already in place, so that we're not, reinventing the wheel every time we go and we make a game. So that's basically what Unity is going to try and do. So what we'll cover today is basically we'll talk about what are like the major concepts that Unity is going to give us. What are the major structures that Unity already has implemented for us, right? Then we're going to write some scripts. Scripts are how you actually build your game, right? They're the code you write that makes your game do what you want it to do, right? And then finally, we'll just talk about some resources and where to go next if you want to continue with some game development. All right, so the first thing we have to know is what a scene is. A scene is just the physical space that a game takes place in. Okay? Um, this is a screenshot from the Unity editor, which just shows a scene, which is a good time to probably mention that if you would like to follow along, you definitely don't have to. But if you happen to have Unity downloaded, you can go into Unity Hub and go in here and select Universal 2D when you go to a new project, and then just name your project whatever you want, and then you can go ahead and create project. I'll be talking for about 10 minutes before I go into the Unity editor, um, which is convenient because this takes about 10 minutes to create a project. Um, so if you want to follow along, I recommend going ahead and starting that right now. But it's definitely not required. Um, so we can chain scenes together, right? So a scene is sort of the place that your game takes place in. And then we can have, say, like a main menu scene. We can have different levels. We can have like a settings menu. So these are all different scenes in our game, and we can kind of define transitions between them, right? So the next thing we have to be familiar with is what a game object is. A game object is anything that exists in the scene, right? And that's purposefully vague because it quite literally can be anything. Um, it can be physical or it can be non-physical. So if we look at a scene like this, for example, um, this is from Overwatch. It's a first-person shooter, so we have different, obviously different players in our game, right? So those players are all different objects. We have different weapons. Those are all different objects. Um, our characters can spawn in like a giant wall. That's also an object. This character has a rocket launcher. That's also an object. Everything that you see, all the environment is also an object. So those are all the physical things that you can kind of see. But there's also non-physical things that can also be considered objects in a scene. So, for example, when a character dies, they have to spawn back in after a certain amount of time. And there's a system in the game that is going to handle that, right? There's some game logic that exists in the world that's going to handle players dying and then spawning back in, right? Um, there's also, for example, objectives that you have to capture in the game to win. So um, there's also going to be some objects in the scene that are handling the logic for what team is winning, what team scores points, right? So objects don't have to have necessarily a physical representation in the game. It's just anything that exists in the scene, right? Um, Game objects also have kind of a hierarchical relationship. So we can have some game objects that are children of other game objects. So if we look at this scene, right, we can have our sort of environment objects, so like the tree, the sky, the grass, right? But we also have our player. But our player has different things inside of it, right? So we have obviously the armor, the helmet, the boots, etc. And then we also have the sword, right? Why do we care about this sort of parent-child relationship with objects? Because every object is also going to define its own coordinate space. So when we have an object like the player has some coordinate system which is considered relative to the player, right? So the helmet or the sword, for example, is considered to be at some offset from the player, right? So whenever the player moves, the helmet also moves. Whenever the player moves, the sword also moves with it, right? So uh, there's also a relationship in space between different objects, right? When we say that an object's location is relative to its parent's location, we call that its local space. So local meaning local to whichever object is my parent. Whenever we're talking about the entire scene as a whole, so the space defined by the scene itself, then we're talking about world space. Okay, so that's going to be an important distinction to make. Um, so we can say that this object, so if we're talking about the helmet, for example, we can always say that it's at some vertical offset from the player, right? And that's never going to change because the helmet is obviously fixed on the player's head. But as the player moves around, its world space does actually change. Okay. Are there any questions so far? All right, wonderful. Um, the next thing we have to talk about is components. So we've looked at objects, and those are kind of everything in the scene, right? But specifically with Unity, it's not like this in all game engines, but one common architecture in some game engines, including Unity, is that objects don't really do anything on their own. So an object, you can think of it as just an empty container. Um, and the only thing that actually gives an object any sort of functionality is a component. So if we're looking at a game like Hollow Knight, for example, we can think about the different things that our objects need to do. So let's like think about the player, for example. The player needs physics because the player needs to not fall through the floor. The player needs a way to read user input and move around. The player needs a way to jump. The player needs a way to attack. The player also has some health, right? So we need to handle the player taking damage, right? These are all things that would be implemented with components. And then you can also think about like the enemies, for example. The enemies need to have some functionality dictating how they're going to move, how they're going to attack. All of that is in a component. And of course, we need to have some functionality dictating how to animate the characters, how to display the characters. All of that is done through components. So you can think of objects as literally just being empty containers. They don't do anything on their own. So Unity gives us a bunch of pre-made components, basically. So for example, we kind of already talked about the transform. A transform just refers to three things in one. It refers to a position, a scale, and a rotation, right? We have a camera, which is like how you're going to see the game. You have a sprite renderer component, which just shows an image, right? Rigid body 2Ds and collider 2Ds we'll use in a second, which are just used by the physics system, right? We have audio sources for playing sounds, animators for playing animations, particle systems for particles. And this next part is where things suddenly start to get interesting. We have scripts. So scripts are just components. Scripts are the code that you write to actually make your game, right? So you can think of everything so far as Unity gives you the structure of how objects relate to each other. And your job as a game developer is to basically write a bunch of components that are going to be attached to these objects to get the game to do what you want, right? So before we sort of get into that, let's maybe get familiar with the Unity editor. This is basically what you get when you just open a scene, right? This is your scene. This is the space your game takes place in. You can see that we already have a couple of objects, right? We have our main camera, which has a transform component, which tells us where the camera is in space, right? And of course, also its, for example, its rotation, right? So you rotate it around. And then we have the camera component itself, right? So there's a difference between the camera object, which can have any number of components, and the camera component, which actually implements the functionality of the object, right? So we can go in here, right? And objects have different data associated with them. This is what we're going to manipulate when we write code, right? So the Unity developers have somehow managed to choose the ugliest shade of blue as a default, so we can go ahead and change that. Maybe we'll do something like this, for example. And then so now we have our background, right? And we have another object here, which is just a 2D light, which is going to actually be used by the lighting system to display our characters, right? So I'm going to go ahead and I'm going to right click here and I'm going to create a 2D object. You can see I can select from some sprites and I can select a square, right? So we have our square right here. Oh, and the main camera needs to be at -10 on the z-axis, otherwise it won't show up. Okay. So we have a square right here. We just created an object, and you can see it has also a transform and it has a sprite renderer component. The sprite renderer component tells us which sprite to render, and we just have a square right now. So I can also change its color. So I want my player to be blue, for example, maybe something like that. And then I can also change the scale of the player to be, say, 0.5, 0.5. So I can drag my player right here, and we can create kind of a little environment for the player, right? So I can rename this object to player, right? And I can create a bunch of squares. So let's say like triangle, and we're gonna make like a weird like forest or something like that. You can do, oh, I made a square. Y'all are getting a preview for the art workshop. Y'all are about to be amazed, right here. Okay, so we can make like a little tree thing, and then we can just like kind of put a bunch of trees around, right? So I'm just Control D to duplicate, and I'm making a bunch of trees, right? So we have this environment set up, right? So we have our scene. Our scene has a bunch of objects contained in it, right? And then all of our objects currently just have a sprite renderer telling us what to display. Okay. So let's actually start to write some code. So basically, anything in a game happens on a frame-by-frame basis, right? So your game runs at, say, 60 frames per second, and you have to basically redraw the entire screen every 60 times per second, right? So let's say we want to add some functionality to our player here. I'm going to go here, and I'm going to add a component, and I'm going to call this player controller. And you can see it gives me an option to create a new script. I'm going to go create an add, and then once it creates that, you can see that I can open it, and we have an empty script right here. Right? So by default, we have two functions in our class. Our class is called player controller. Every script is a class, and every script inherits from a different class called monoBehavior. What monoBehavior does is it tells you that this is a class that is meant to be attached to an object, right? So that's all that monoBehavior means. And you can see it already gives us kind of a description. Start is called whenever the game object sort of is spawned into the world, right? So the moment we press play, our player exists in the world, and then so we call start exactly once. This is where you do all of your setup, right? You can think of this as sort of similar to a constructor. It's not exactly like a constructor, but it's called on the first frame. So this is just where we're going to do our setup code. And then update is going to be called every frame. So you can think of this, even though it's just a function call, you can think of it as kind of a loop. You can think of it as a loop that anything that goes in here is going to happen however many times a second our game is running, typically 60. But we'll see that that can kind of vary quite a bit. Are there any questions so far? All right, so let's add some basic functionality to our player. So 90% of the code that you write in Unity is going to look something like this. You're basically going to, in your update loop, you're going to read the data of some component. So you can see how, for example, we changed the color of our sprites, right? That's an example of a piece of data that exists in a component. We're going to read some data. We're going to have some logic that happens in update, and then we're going to decide sort of what the new data of the component should look like. And then that process is just going to repeat. So we just need to decide basically how to modify our components, right? Whenever we're in our update loop. Okay. So what that might look like is we have a variable, which is of some type component, right? And at the start, we're going to do our setup and get a reference to that component. It quite literally is just a function called getComponent. And then in our update function, we're going to do some work. And then finally, we can modify the different variables of our components because these are just like classes like any other, right? So let's do like a basic player controller where we're just going to move up, down, left, right. Okay. So the first thing I need is a reference to speed. It's just going to tell me how fast the player is going to move. So I have a serialized field tag that when I go into Unity, you can see that when the script compiles, you can see that I now have a speed variable that I can modify here, right? So that's what a serialized field does. It's just a variable that's going to be shown in the inspector. So when I go back here, make this slightly bigger. Maybe we can get rid of these comments here. We need a reference to the component, right? So I want to move the player around, so I'm going to get a reference to a transform component. So transform. And then in start, we're going to go transform equals getComponent transform. Okay. You'll see it gives me a warning here because turns out accessing transform, like that specific component, is so common that the class mono behavior just gives you a reference to transform itself, right? But we'll do things the long way for now, just so that you can see an example of how to use sort of getComponent. But transform is such a common component that we can just access it directly without having to do much anything else. And then so now I'm going to read some user input. So I can say if input.get key get key, and I want to do WASD, so my right key is going to be keycode.d, and then we'll have some move input. Our move input is going to be stored in a vector2 that's going to start off as vector2.0. So a vector2 is just a vector with two components, an x and a y. So if I am holding down D, then I want move input.x equal to 1. If I'm holding down A, then I want move input dot x to be -1. If I'm holding down W, then I want move input dot y to be 1. And if I'm holding down S, then I want my move input dot y to be -1. Okay, so we're just setting our move input based on what every frame we're setting our move input based on the based on WASD keys. And then so what I can do is I can say something like transform.position plus equals position is always a vector3, so what I'm going to do is I'm going to cast this to a vector3. Move input sorry, move input times speed. So we're just taking the vector and scaling it by speed. Okay? And this is not going to work, and we're going to see why it's not going to work, and then we're going to fix it. But if I go in here and I do something like this, so let's set speed equal to something like 1, what you'll see is that if I go here, the character kind of flies off the screen. Okay? The reason it's doing that is because, remember, update is happening every single frame, right? So if every frame we're moving over 1 unit is exactly one of these. So 60 times a second, we're moving over one of these units, okay? So then you might think the solution is to just make move input speed really small. So it's like, okay, fine, we'll make it 0.01, right? And you can see that kind of improves things, but our frame rate is not guaranteed. So we're not guaranteed to have exactly 60 frames per second. It could be more, it could be less. Like 1 minute you're playing your game and it works perfectly fine. The other moment you open like 30 Chrome tabs and then everything, suddenly your game is really slow. So what would happen if this game suddenly started to become really slow is my character would also start to become really slow, right? So what we'd like is to be able to do this independent of frame rate, because our frame rate is unknown. It could change based on different people's computers. It could change based on anything, right? So we don't want our code to rely on a specific frame rate. So what we can do is use this variable called time.deltaTime, and that's going to tell us what the real-time difference from now to the last frame was. So this is our problem right here, where if we just increase the transform by some amount, right? If we're moving 10 frames per second, right, then we'll move over 10 times in 1 second. And then in 1 second, we moved over twice as much as we would have if we had moved over with 5 frames per second, right? But instead, if we multiply by delta time, right, then every time step we move a fixed amount, right? Because this is based on real time, right? So with delta time being 0.1, we move forward 0.1. And then so with 5 frames per second, we move over twice as much because delta time is twice as much. So then our speed is consistent. So after 1 second, both objects have moved the same amount, right? So this is why we have delta time. So if we want to fix our code here, right, what we can very simply do is multiply by time.deltaTime, right? So now we've changed it from being dependent on the frame rate to being sort of moving over a fixed distance over some unit time, right? Does everything kind of make sense so far? All right, wonderful. So if I go back to Unity, you can see I don't have to make this some absurdly small number. I can use a number like 5, right? And I can go in here, and you can see that we move at a reasonable speed, and if my computer were to suddenly become really slow, it would just be stuttery, but it would move at the same speed, right? Interesting thing that happens is if I go diagonally, am I moving faster or am I moving slower? I'm moving faster, right? Does anyone want to take a guess at why that is? Yes, exactly. So if we are moving up and to the right at the same time, right, our move input vector is 1, 1. And we know that has a length of square root of 2, which is about 1.4-ish, right? So we're actually moving about 40% faster on the diagonal, right? So the solution there is simply to just normalize, and Unity gives us a very handy normalize function. So we take our move input vector, we normalize it so that way it has unit length, and then when we go back, we should see that we no longer have that problem. Okay. All right. So now let's talk about the physics system. Basically, we have 2 update loops. So we've talked about update. And we've already kind of talked about how update is, we don't know how fast it's going to run. It could be faster on someone's computer, it could be slower on someone else's computer. We really have no idea. It could fluctuate. It can be kind of a mess, right? Turns out physics systems really, really don't like like when that happens. We want our physics systems to have what we call numerical stability, right? So Unity has a somewhat unintuitive solution to this, which is to say we're going to have two update loops. We're going to have one update loop, which is where we're going to put all of our game logic, our normal things that we would calculate at every at every frame. But then we're also going to have our fixed update, which is where we're going to do our physics calculations. And that's going to be 50 frames per second by default, right? So that's going to ensure some amount of stability when we're working with physics. So instead of just directly setting the player's position, right, I'm going to set up a quick 2D platformer scene. So I'll get rid of this, and then sort of very quickly I will grab some squares, and then we'll set up a scene here for kind of like a simple platformer. Right here, something like this. So we have kind of a simple platformer scene set up. Now I'm going to start adding some physics-based components to this. So I'm going to go in here and I'm going to add a box collider 2D, right, which you can see defines some collision bounds for these objects. And I'm going to go into my player and I'm going to go and add a rigid body 2D, right, and I'm going to add a collider, right. So the rigid body 2D just tells the physics system that this is an object that's going to move based on the physics system, right? So you can see we have some variables here. So for example, for gravity, I like to turn up the gravity scale. I think 1 is a little bit too small, so we can do something like that. I also don't want my player to be randomly rotating around, so I'm going to set a constraint on the z-axis, right? And then these are some settings that I won't explain right now. But if you're curious, Unity actually has very good documentation on what they do, but it's a little bit outside the scope of what we're doing right now. But I'm going to set this to interpolate, and I'm going to set this to continuous. And then, so when we start the game, what we should see is, and I'll go ahead and get rid of this in update, because we're going to somewhat rewrite this code. So what we'll see is that now the player falls, and the player lands on the ground, right? So we didn't tell it to move, right? All we had to do was give it a rigid body. We told it what gravity scale we wanted. We told it we didn't want it to rotate, and then the physics engine handles all the rest, right? So all of those physics updates are happening at a fixed 50 frames per second, and that's what's going to help with that stability, right? So if we want to move with the physics system, so not just directly setting objects, what we can do is we can influence the velocity of the rigid body. So what I'm going to do now is we'll make a simple platformer game. So we'll move left and right, and then we'll have a jump mechanic. Okay. So just to get a simple left and right moving, we already have our speed. I need, as we talked about before, a reference to our rigid body 2D. I'll call that RB. This one we do need to say RB is equal to get component rigid body 2D. And then I can go in here and I want to move right and left. So I'm going to make a float here. I'll just call it input. And Unity actually gives us a very handy method we could call input.getAxisRaw horizontal. What this is going to do is when I'm holding right, it's going to be 1. When I'm not holding anything, it's going to be 0. And when I'm holding left, it's going to be -1. So this gives us 3 possible values of 1, 0, or -1. Okay? And then what I can do is once I've read my input, I can go in here and I can say in my fixed update that rb.linearVelocity is equal to a new vector 2, right? And we want to move right and left, so we'll go input times speed. And then the y velocity, we're just going to hold that constant. So we're going to go rb.linearVelocity.y. Okay? So we're directly setting the x velocity to be right or left based on what our input is, right? And our rb.velocity.y is just going to stay the same, okay? Does everyone understand why we did this in update and why we did this in fixed update? Right? Because this is directly interacting with the physics system. We're directly setting the velocity of a rigid body. Therefore, that's a physics calculation that has to happen in fixed update, right? And we shouldn't put everything in fixed update because, so you might say, okay, well, 50 frames per second guaranteed, that's pretty nice, right? So I'll put everything in fixed update, and then my game will always run at 50 frames per second. If you put too much, so if you start putting all of your game logic in fixed update, then Unity won't be able to keep up with the 50 frames per second, and then your physics will start to just explode. So you want to keep as much as possible outside of update, let Unity decide how fast it wants to run your game, and then let the physics engine kind of be separate, right? So you want to sort of only put physics-related things in fixed update, okay? So now that we've done that, what we should see is that when we go back, I can go and I can hold left and right, and then we have our left and right movement, okay? But now we need to have some jump, okay? So what we need to do now is have some way to detect when the player is on the ground, okay? So we can do what's called a circle cast, which is we're going to basically spawn in a circle, and we're going to test, and we're going to see what objects are within that circle. We're going to spawn a small circle just at the player's feet, and then if we're overlapping, so if the player's feet are on the ground, then we can say it's on the ground and it's able to jump, okay? But first we need some way to tell, what the ground is versus any other object, right? So one way we can sort of differentiate different objects from each other is with something called a layer mask. So I'll call this the ground layer, right? And it's serialized sealed because we'll set this in the editor. And what we'll do is we'll basically say we'll have a Boolean for is grounded. Okay? And by default it'll be false, but we want to set is grounded equal to physics2d dot overlap circle. And you can see this takes a few parameters. The first one is a point, right? So what I can do here is I can have, remember how we talked about parenting? So I'll have some other object that's going to be a child of our player right at the feet position. So I'll call this feet position, right? So at feet position dot position, we'll spawn a circle. It can be just a tiny circle, something like 0.1f. And then we want to give it a layer, right? So we're going to spawn a circle at the player's feet with a small radius of like 0.1. And we will check and see if there's anything in the ground layer that collides with that circle. And if that's the case, then we're on the ground and then we can jump, right? So we'll say if is grounded and input dot get key down. I'll use the space bar to jump. So key code dot space. Then I can set RB linear velocity is equal to new vector 2. In this case, we're going to hold the x velocity constant. So we'll go RB dot linear velocity dot x, RB dot linear velocity, and then we'll do some kind of jump force, so we'll make that a separate variable. Jump force. And then so we'll set the y velocity to that jump force. Okay. The reason that I set rb.linear velocity in fixed update here, but in here I set it in update, is because when you jump, that's kind of a one-off action, right? It's not a continuous update, right? So we're not really getting any benefit from sort of the fixed update, right? Because fixed update here is we're continuously setting the velocity, right? On the other hand, if I just jump, I press the spacebar, I jump, and that's it, right? So in that case, for a one-off action, it's usually considered safe to just go ahead and do that in update, right? Because here, the moment we read the input, then that's when we want to jump, okay? So that's why it's safe to do this in here, okay? So I can go back, right? And you can see that now we have some different variables for us to set. So our jump force, I'll set that to something like 10. We can set our ground layer to, I haven't defined my ground layer yet, but if I go here, I can select all of these objects and I can go into the layers panel. And you can see there's a spot for us to add new layers. So I can go and make a ground layer. And then so when I go in here, I can select the ground layer for all of these. And then so I can go in here and select my layer mask. So I can select what I want to consider the ground. So I'm going to call that the ground. And then I can make a new object here. Just any 2D object, it can be empty right here. And then this is going to be feet position, right? And then so remember we talked about the parenting. No matter where and how my player moves, right? This position is going to just stay the same, right? So I can go ahead and I can put this down here at 0, negative 0.5, right? I can put this right here, right? And I can move my player around, right? I can move my player around anywhere I want, and the feet position just stays there, right? So you can see that this, the position of this object is always inherited from this one, right? So then what I can go in here and say is that feet position is going to be equal to this object. And then now when I go and play the game, you can see I go on the ground and I can jump now. And you can see even if I hold space, it won't actually let me jump until I've actually touched the ground. Okay. Are there any questions so far? All right, wonderful. Okay. So basically some resources if you are interested in learning more about Unity. So we have EGADS, we're the game development club at UT Austin. We do art and Unity workshops just like this. We do them basically about 5 times per semester. We cover a variety of different topics. We also have speaker nights, so we have people from industry that come in and actually talk about their experience and share that with us. We have dev nights, which happens every week, where we have some people working on an actual game, and it's very beginner friendly. You can join in if that's something you're interested in doing. And then we also have game jams. So game jams are basically like hackathons, but specifically for game development, right? So EGADS hosts a Texas game jam every fall semester. We also usually host one over the summer as well, right? And those are, in my opinion, some of the best ways to sort of learn more about game development is just by making a game, right? So in my opinion, tutorials will only get you so far. Most of what you learn, because Unity is any game engine at all, is such a big complex system. You really can't study all of it before you go and actually do something. A lot of the learning just comes from, I want to make a platformer, I'm going to search up how to make a platformer, right? So our game jams are also very beginner friendly. We have team matching, so if you want to be team matched with someone, if you don't have a group to do it with, you can sign up to be team matching, and we pair you up with a team. So anybody there would be happy to explain. We also do workshops in preparation for the game jam as well. So that's also a great resource to take advantage of. And we do a showcase at the end of a game jam. In my opinion, the best part of a game jam is when you get to actually see someone play your game. And that's where you kind of learn the most about game design. So we do an in-person showcase after the game jam. So you can literally see people playing your game, and that's probably the most valuable feedback that you'll get. On the other hand, there's a website called itch.io. You can think of it like it's basically a game store. It's like Steam, but just on the web, right? They also host a ton of game jams. So if you go to itch.io and you go to the game jams tab, you can see there's a game jam basically every weekend. There's tons of different options. Some are more beginner oriented, some are more advanced oriented. A lot of the times they have different themes that focus on different kinds of games. they're also varying lengths of time. So they usually vary between about 48 hours to sometimes even a full week, right? So if you ever have like a free weekend or over the summer or over winter break or spring break and you just want to make a game, you can always go onto itch.io and there's always going to be some game jam going on. So those are really great resources because it kind of works around your schedules. You don't have to have a particular weekend free. You can just pick whatever weekend you're free and you can find some game jam. Um, Game jams are probably where you will learn the most. Um, but YouTube also has it's completely flooded with just a ton of like really excellent resources. One of the advantages of Unity is that it is certainly the most popular game engine, especially with sort of indie developers. So there's just a ton of resources, a ton of documentation. Um, I had considered listing some YouTubers here, but honestly, if you search up how to do X in Unity, pick the top results, and it's probably going to be really great. Yes,
Any YouTubers you might recommend?
absolutely. So I learned a really long time ago. So like a lot of those YouTubers, those tutorials might not be super up to date. Um, but I think Brackeys' tutorials are probably great. So Brackeys is one YouTuber. There's another YouTuber called Code Monkey. He makes really great stuff. There's also a YouTuber called Sebastian Lag, who does these kind of coding adventures, and he does them in Unity, and he does some like really like crazy stuff, and it's super educational, and those are also really great. Um, but quite literally, any popular Unity tutorial is going to work just fine. It's also just it has really that benefit that it's so popular that there's so many resources. Um, on top of that, Unity's documentation is also really good. Um, I think I have been spoiled by Unity's documentation because when I see documentation for other tools, um, Unity's is just very good in comparison. Every function in Unity has a detailed list of parameters. It has an explanation of what those parameters do, and it has a code example for any function you can imagine. So Unity's documentation is a great resource. They also have a lot of beginner resources on their documentation. So kind of everything that I explained uh, just now. Um, there are everything about scenes, everything about game objects, everything about the physics system. They also lay it out there in a very clear way. So if you ever sort of are wondering sort of anything sort of fundamental about how Unity is structured, they lay it out there in their documentation. So Unity's documentation is also great. If you're interested in game programming, not specifically with Unity, but just like game programming in general, then the book I would definitely recommend is Game Programming Patterns. The best part of this is it's completely free. It's on the web, so you can just read it. Um, and that will go through sort of all of the low level design patterns that go into games. So everything from designing an update loop to designing um, different data structures that go into a game, different uh, software engineering patterns to kind of organize your code as well. This is a really great book if you're interested in more, not just Unity specific, but game programming in general. I would definitely recommend that book. Um, but yeah, if y'all are interested in joining EGADS, that's all I have for the Unity portion of this. So we'll go ahead and switch to our art workshop officer. All of our communication is done for Discord. So if you scan this link, you can join our Discord server. Yeah, thank you all for coming. I hope you all learned something new about Unity, and I look forward to seeing some of y'all on EGADS.